Hello friends and welcome back to my channel. I am Ashfaq. Today we will create a complete DevSecOps project using Jenkins, SonarQube, Trevi, Docker and the Kubernetes. This CI/CD pipeline will work in complete automated manner. Any change on the GitHub repository will trigger the pipeline, and once pipeline execution is completed, you will see the changes appearing on the application, which we will deploy on the Kubernetes. In short, I will explain you the flow of our today's project. First of all, we will use the Terraform to create the instance for the Jenkins, and all the packages we will install in that instance using the Terraform itself. In our CI/CD pipeline, if user makes any change on the GitHub repository, it will trigger the pipeline, and our pipeline will start executing the stages. First of all, it will do the SonarQube analysis of our code. Then it will perform the npm dependencies install, and then it will do the Trevi fs scan of our code, and then it will build the Docker image and it will push that Docker image to the DockerHub. Then it will scan that Docker image using Trevi, and then finally our Jenkins script will deploy the pods on the Kubernetes using the DockerHub image, and we will have the monitoring configured using the Prometheus and the Grafana, which will monitor the EKS cluster, and it will also monitor the Jenkins. And after completion of the every build, we will get the email notification on our Gmail ID with the Trevi scan results and the complete log of the job completed. So let's start building our project. This is my Windows 10 system in which I am having Visual Studio Code and the AWS CLI installed. You can download the Visual Studio Code from here, and you can download and install the AWS CLI from this page. I will create the folder for my project, and inside it I will create one more folder called Jenkins SonarQube VM. On the Visual Studio Code, I will open the folder which I have created, and on this folder Jenkins SonarQube VM, I will create one file main.tf, and I will paste the content for the main.tf. So all these content for the main.tf file is available in the description section. So this is the AMI. You need to change it as per your region. Instant type, I'm going to create T2 large. This is my key name for the Linux server, and this is the user data file install.sh, which it will run inside the created EC2 instance. It will give the name to the EC2 instance Jenkins-SonarQube. Disk size would be 40, and it will also create the security group. Note one thing here, we don't need to create the VPC because every account has the default VPC. If I go to my account and VPC, so this is the default VPC in my account. So we don't need to create the custom VPC once again. It will just associate these security group to the default VPC of the account, and it is also going to open the inbound port 2280 8080 for the Jenkins, 9000 for the SonarQube, and 3000 for our application. And this would be the name of the security group. I will save this file. I will now create the one more file, provider.tf, and I will provide the content in this file. Here actually defining we are registering the uh, provider, which is the AWS. This is my region AP South 1. I will save this file, and finally I will create the install.sh file, which it is going to run inside the created EC2 instance. So this install.sh file will first update the packages, then it will install the JDK, then it will install the Jenkins in our EC2 instance, then it will install the Docker in that instance, and then it will run the SonarQube as the container in the EC2 instance. This is the image name for the SonarQube, the standard image of the SonarQube. And after that, it will install the Trivy in that EC2 instance. I will save this file also, and the path for this install.sh we have defined here on the main.tf. I will now go to AWS console. I am users. We are actually going to create the one user through which we will log into AWS from the command line. Create user. I will give the name cloud user. Next, attach policies directly. I will give the full access to this user. Next, and create user. I will go to user, security credentials, and here I will click on create access key. Command line interface, I will tick here. Next, description I will give cloud user, create access key. I will copy the access key. I will go to VS Code, and on the folder I will right click and select this option, open in integrated terminal. On the terminal I will give the command AWS configure. I will paste the access key and hit enter. I will copy the secret key from here and provide it on the terminal. So we have successfully logged in from the terminal. On the AWS console I will download the CSV file and I will click on done. On the VS Code I'm inside this folder. I will give the command Terraform init. Okay, so Terraform has been initialized in this folder. I will now give the command Terraform plan. Okay, so it is going to create these resources in our AWS account. And finally, I will give the command Terraform apply auto approve. Instance created. If I go to AWS console, instances, it is not showing the instance because we have taken the region AP South 1 and we are inside the Ohio as of now. So I will change my region to AP South 1. So this is the instance which has been created. And this is the security group which has been created. If I go to security group, so these are the inbound rules which has been applied as per the Terraform script. I will copy the public IP of the instance, and on my local system I will go to terminal session SSH. I will paste the public IP. Username I will provide Ubuntu advanced, use private key, and I will select my key. If I give the command Jenkins -FN version, so Jenkins has been installed in my system. If I give the command Docker-FN version, so Docker is also installed. And if I give the command trivi -FN version, sorry, So this is the version of the Trivy which has been installed in my system. If I give the command docker ps-a, so this is the container for the SonarQube which is running, created about a minute ago, and we are actually running the SonarQube as the container on this EC2 instance. You might be doing this project in multiple settings. So while you are shutting down your EC2 instance, you need to first stop the Docker container. First give the this command docker ps-a. You will get the ID for the container, and then give the command docker stop and the container ID. After that you can shut down this EC2 instance, and once you are back, you need to give the command docker start to start the SonarQube. We have installed the EC2 instance for the Jenkins and the SonarQube. Now we need to configure the SonarQube in, sorry, we need to configure the Jenkins in that EC2 instance. So I will browse the public IP of the instance with the port 8080. I will go to this path on the terminal and copy the password. Install suggested plugins. I will create the user cloud admin. I will set the password. Okay, so we are inside the Jenkins dashboard. Now we need to install the few plugins which are required for our project. So I will go to manage Jenkins, plugins, available plugins, and first plugin I will search here, Eclipse Timurin installer, this one, and then I will select Sonar. I will search here SonarQube. I will select SonarQube scanner, and I will search here gates. I will select Sonar quality gates. I will search here Node.js. I will select the Node.js also. Then I will search here Docker. So I will select Docker Commons, Docker Pipeline, Docker API, and Docker build step. I will click on install. Okay, so plugins installed. I will again go to manage Jenkins. Now we need to install few tools which are required for our project. So I will go to tools and I will go to JDK installation and I will click here on add node.js. I will give the name node 16 install automatically install from nodejs.org and the version I will select node.js 16.2.0, this one. Now I will go to next tool which is JDK. JDK installation. I will click on add JDK. Name I will give JDK 17. I will close this. Add installer. Install from adaptium.net and the version I will select 17.0.8.1+1, this one. And next is Docker. Docker installations. I will click here on add Docker. Name I will give Docker. Install. I will tick on install automatically. Add installer. Download from docker.com. And the next tool is SonarQube. So under the SonarQube scanner installation, I will click on add SonarQube scanner and the name I will provide Sonar scanner. I will keep the tick here install automatically. Install from Maven Central and version is fine. I will click on apply, then save. We have configured the Jenkins. Now it's time to configure the SonarQube. So I will copy the public IP of the instance and I will browse it with the port 9000. I will provide the default credentials which is admin. I will set the new password. I will go to administration, security, users. I will click here, update tokens. I will give the name for Jenkins, token for Jenkins, and I will click on generate. Copy this token somewhere on your local system. I will go to Jenkins, manage Jenkins, credentials, add credentials, and type I will select secret text. ID I will give SonarQube token, and here I will provide the copied secret which we had create. Now I will go to manage Jenkins, system, and actually we need to add the SonarQube server here. So I will go to SonarQube servers, add SonarQube, name I will provide SonarQube server, and the URL I will copy the private IP of the instance, and I will provide here http colon slash slash IP address colon 9000, and the token I will select which we had created just now, apply and save. I will now go to SonarQube dashboard, and I will go to quality gates, and we need to create the new quality gate here. So I will click on create, and I will give the name SonarQube quality gate, save. Now we need to create the webhook between SonarQube and the Jenkins. So I will go to administration, and under the configuration I will go to webhooks. I will click on create, name I will provide Jenkins, and for the URL I will copy the private IP of the instance, and I will provide it here. http colon slash slash private IP of the instance colon 8080 slash SonarQube webhook, and I will click on create. We have configured the Jenkins, we have configured the SonarQube, and we have integrated the SonarQube with the Jenkins also. Now it's time to create the pipeline. So first of all, I will create the token on the SonarQube for our project. So on the SonarQube dashboard, I will go to manually. I will give the project display name, and I will give the project key name also, which is the same as of project display name. Main branch, I will click on setup. I will click on locally, and I will click on generate. This is our token name, which is being used, which will be used in our project. And I will click on generate. Continue. Other Linux. So these are the command which would be used in the script. So I will go to Jenkins dashboard, new item. I will give the job name YouTube-CICD pipeline. OK. I will click on discard old builds. Max of build to keep, I will type 2. I will not set any trigger as of now, and I will directly come here on the script portion. I will give the script. In the script, first of all, we are recalling our tools, JDK 17 and Node 16. These two we had installed in our Jenkins, and this is the name of our SonarQube scanner added in the Jenkins Sonar scanner. And in the first stage, it will clean up the workspace. Then it will do the checkout from the Git. So this is my GitHub repository, and then directly it will come to SonarQube analysis stage. This is the server name, SonarQube server, which we have added in the Jenkins, and this is the scanner, Sonar scanner, and this is the project name, and this is the key name which we have generated in the SonarQube. And under the quality gate stage, this is the token which was created in the Jenkins SonarQube token. Then it will install the dependencies, and then it will perform the Trivy FS scan. I will click on apply, save, and I will click on build now. Job completed. If I go to SonarQube dashboard projects, so this is the analysis of our project. If I go to issues, so these are the issues found in our project during the SonarQube scan. Now we need to configure our pipeline to build the Docker image and push that Docker image to the DockerHub. So I will go to DockerHub. First of all, we need to create the personal access token, and add that token into the Jenkins. So you can go to user my account security and you can create the access token here. I have already created the access token. So I will go to Jenkins, manage Jenkins, credentials, add credentials, username with password. Username, I will provide my username of the DockerHub, and password, I will paste my personal access token. ID, I will provide DockerHub. Description, I will give DockerHub. Create. Now I will add the two stages into our Jenkins pipeline. I will go to my job, configure, and I will add the two stages. Okay, so first stage is Docker build and push. So this is the credentials which we have added, and this is the tool name which we have given Docker. So using first command, it will build the Docker image, and this would be the name of the image, YouTube-clone. Then it will tag the local image according to the Docker Hub. This is my Docker Hub username, and this would be the tag latest. Then using this command, it will push that tagged image to the Docker Hub, and once it is pushed, it will do the tree scan of the Docker Hub image. This is the image on the Docker Hub. I will click on apply, save, and I will again click on build now. job completed. And if I go to DockerHub and do the refresh here, so you can see here the image has been pushed here just now. In this section of the video, we will set up the monitoring with the help of Prometheus and the Grafana. And for the Prometheus and the Grafana, we will create the separate instance. So I will create the new folder under my project folder called monitoring server, and on the VS Code I will go to that folder monitoring server, and we will create this instance with the Terraform. So I will first create the main.tf file under this folder. I will paste the code. So this is my AMI. You need to change the AMI as per your region. The instance type I am going to create is T2 medium. This is my key, and it will install the it will run the commands in the created instance using the install.sh file, and the name of the instance would be monitoring server. Disk size would be 20, and it is going to create the separate security group monitoring server SG, and it will create the inbound rule also, and it will allow the port 2280.443.9090 for the Prometheus, 9100 for the node exporter, and 3000 for the Grafana. It will create the outbound rule also. I will save this file. I will close the previous files, and then I will create the provider.tf file in which we will register the AWS provider. So I will create the separate file and name it provider.tf. I will give the content. This is going to register the AWS provider in the region AP South 1. I will save this file also, and then finally we need to create the install.sh file through which we are going to run multiple commands in our newly created EC2 instance, and these commands would be run via Terraform itself. So I will go ahead and create the file here, install.sh, and I will paste the commands for this file. So in short, I will explain you what are the packages we are going to install using the install.sh. First of all, it will do the system update, and then it will download the packages for the Prometheus. Then it will create the uh, system service for the Prometheus. Then it will start the Prometheus service, and then it will download the packages for the node exporter, and then it will create the system service for the node exporter, and it will start the node exporter service, and then finally it will install the Grafana and it will start the Grafana service. I will save this file. I will open the integrated terminal and I will do the Terraform init. Okay, so Terraform initialization completed. Under this folder, I will give the command Terraform plan. Okay, so it is going to create these resources. Finally, I will give the command Terraform apply auto approve. Okay, so creation completed. If I go to AWS console and do the refresh here, so this is the instance which has been created. If I go to security, this is the security group which has been created, and these are the inbound rules added to the security group. I will copy the public IP and I will access it over the terminal. And if I give the command sudo systemctl status Prometheus, so Prometheus is running. And if I give the command sudo systemctl status node exporter, so node exporter is also running. And then if I give the command sudo systemctl status Grafana server, so Grafana server is also running. If I go to AWS console, copy the public IP and browse it with the port 9090, so I can see the Prometheus dashboard. If I go to status targets, so only the target local target is showing here. We need to add the target for the node exporter. So on the terminal, I will go to directory etc/Prometheus, and then I will open the file prometheus.yml, and here we have the job for the Prometheus. Below that we need to add the job for the node exporter. Here I will add the job below this line. Job name would be node exporter I will give the next line static configs and here I will provide the public IP of the monitoring server colon 9100 is the port number for the node exporter. I will close the comma, I will close the bracket, I will save this file, control O and enter to save, control X to exit. Now we need to check the indentation of the YAML file. We can check this with this command. So showing success means indentations are correct. Now we need to reload the service, which we can do with this command. And if I go to dashboard of the Prometheus and do the refresh here, so node exporter job is showing, and it is up. We can see the metrics, so logs are coming. Now with these logs we need to create the dashboard on the Grafana. So I will browse the public IP with the port 3000 to access the Grafana. Admin I will set the password. Okay, so we are inside the Grafana dashboard. So we need to now add the data source. So I will go to data source. I will select the Prometheus. Name would be Prometheus, and here I will provide the URL http:// and the public IP of the instance colon 9090. This is the URL for the Prometheus, and remaining things I will keep as it is. I will click on save and test. So it is showing successfully queried. I will go to home, and here I will search the import dashboard, and here actually we need to give the dashboard ID. So for the node exporter, the dashboard ID is 1860. You can search on Google. Node exporter Grafana dashboard, and open this link and copy the ID to the clipboard and paste it here. So it is 1860. Load, and here select the source which we have created, Prometheus, import. So here we can see the dashboard for our monitoring server using the node exporter. Multiple dashboards are available. Now we need to integrate the Jenkins with the Prometheus so that we can import the dashboard for the Jenkins also on the Grafana. So I will go to Jenkins, manage Jenkins, plugins, available plugins. I will search here Prometheus, and I will select this plugin Prometheus Matrix, and I will click on install. So it is asking to restart. I will click here. The Jenkins is restarting. I will log in again. I will go to manage Jenkins, system, and under the system here is the Prometheus. Path is Prometheus. I will take these two options also, and the job name is Jenkins underscore job. I will click on apply and save. I will go to terminal of the server, and here I will again go to cd etc Prometheus. I will open the Prometheus.yaml file, and here I will add the job for the Jenkins. Job names Jenkins underscore job, and we will have to provide the matrix path. So metric path is Prometheus Then we need to give the static config. Targets colon, I will open the bracket, and here I will give the public IP address of the Jenkins server. Colon 8080. I will close the bracket. I will save this file. Control O and enter to save. Control X to exit. And I will run the command to check the indentation of the YAML file. It is showing the error. I will open the file again. 33. I will go to here. This extra space we need to remove in both the lines. I will save this file. Control O and enter to save. Control X to exit. I will again give the same command. Okay, so now it is successful. I will reload the service. If I go to Prometheus dashboard and do the refresh here, so Jenkins job is added. Data fetching may take some time. Now this target is up. If I open this link, so the log is coming. Now we need to add the dashboard for the Jenkins on the Grafana. I will go to Grafana dashboard, and here I will search import dashboard and type dashboard ID. I will give 9964. You can search also on the Google Prometheus Jenkins dashboard for the Grafana. 9964. I have given the ID for the dashboard. I will load it. So the name of the dashboard is it has taken. I will select the source Prometheus and import. So this is the dashboard for the Jenkins. Executor free 2. I will go to Jenkins. I will go to job and I will click on build now. job completed. If I go to Grafana dashboard and do the refresh here, so the successful job is showing as 1 now. After integrating the Jenkins with the uh, Grafana, we have the successful job quantity as 1. In this section of the video, we need to create the email alert for our job in Jenkins. So I have logged into my Google account and I'm inside the myaccount.google.com, and your account must have the two-factor authentication enabled. I will go to security. I will search here app password. I will give the name and I will click on create. Copy this to your system and close. Now we need to enter these credentials into the Jenkins. So I will go to Jenkins, manage Jenkins, credentials, add credentials, username with password. Username, I will provide my Gmail address. And I will provide the created password here. ID, I will give Gmail. Description, I will give Gmail, and I will click on create. Now I will go to manage Jenkins, system, and I will go to email settings. SMTP server, I will provide here smtp dot gmail.com. Default user, I will provide my email ID. I will go to advanced. I will take here SSL, SMTP port 465. I will click on test. I will provide here my email address, test configuration. I will tick here use SMTP authentication. Username, I will provide my username, and password I will provide which we have created. I will again click on test configuration. Email was sent successfully. If I go to my Gmail, I have received the test email from the Jenkins. I will now go to extended email notification server. I will give smtp.gmail.com, port 465, advanced credentials. I will select the credentials which we have created. Gmail, use SSL, default content type. I will select HTML, and under the triggers I will select always and success. Apply and then save. Now we need to modify the pipeline script and we need to give the post. So I will go to my pipeline, configure. I will go to script and here after the stages I will provide the post. I will click on apply and save. I will click on build now. Job completed successfully. And if I go to my Gmail account, I have received the email from the pipeline which has the complete build log along with the Trevi file scan result and Trevi image scan result. In this section of the video, we are going to configure the AWS EKS. So I have taken the remote of the Jenkins SonarQube server. First of all, I need to install the kubectl in this server. So I will give the command to install the CURL. Then I will download the package for the kubectl. Then I will install it. If I give the command kubectl version. So this is the version of the kubectl which has been installed. Now I will go ahead and install the AWS CLI in this server. So first of all, I will download the packages for the AWS CLI. I will install the unzip in this server. I will unzip the downloaded package. And then I will install the executable file. If I give the command aws --- version, so this is the version of the AWS CLI installed in my system. Now I need to install the EKS So first of all, I will download the packages for the EKS using this command. These packages has been downloaded in the TMP folder. So I will go to TMP directory and I will move the TMP, sorry, executable file to the bin folder, because all the executable files are under the /bin. If I give the command EKSCTL version, so EKSCTL has been installed in my system. Now we need to create the IAM role and attach it to the EC2 instance. So on my AWS console, I will go to IAM roles, create role, AWS service. In the drop down, I will select EC2. Next, I will select the administrator access. Next, I will give the name EKSCTL underscore role. Create. So role has been created. I will go to my EC2 instance. I will go to actions, security, modify IAM role, and in the drop down I will select the created role, update IAM role. Okay, so role has been assigned to the EC2 instance. Now I will go ahead and create the EKS cluster using the EKSCTL. So I will give the command in which this would be the name of my EKS cluster. I will hit enter. Then I will select my region AP South 1. Then I will give the node type T2 small. Then I will give the node count 3. This Kubernetes cluster creation will take some time. So I will pause the recording here and I will resume it once it is completed. Kubernetes cluster creation completed. If I give the command kubectl get nodes, so these are 3 nodes created in my cluster. If I give the command kubectl get svc, so this is the default service of my Kubernetes cluster. Now we need to configure the monitoring for our Kubernetes cluster. So we will install the Prometheus on the EKS cluster, and then we will add the Prometheus as a source to the Grafana dashboard. So to install the Prometheus, first of all we need to install the Helm on the server. So I will install the Helm. If I give the command Helm version, so the Helm has been installed in my system. Now we need to add the Helm stable charts for our local client. So for that I will give the command then I will add the Prometheus Helm repo. Then I will go ahead and create the separate namespace for the Prometheus. And then finally I will go ahead and install the Prometheus using Helm. Okay, so it has been installed. I will now give the command to check the Prometheus has been installed or not. So I will give the kubectl command, kubectl get pods namespace Prometheus. So these are the pods created in the for the Prometheus. Then I will check the service which has been created for the Prometheus. So this is the service created for the Prometheus, but not the these are not the load balancer service. So these are not exposed to the external world. So to expose the service to the external world, I will open the file, and in this file I will go to end, and here type is given as cluster IP. So I will type I button to insert, and I will make it load balancer. And then this port I will make 9090. I will go ahead and save this file. I will press escape button, then colon WQ and hit enter. If I can give the command to check the service, so now you can see we have the load balancer service instead of cluster IP, and this is the external DNS for the service. I will copy this URL, and on the browser I will browse it with the port 9090. So you can see Prometheus is ready and it has been installed on the Kubernetes cluster. I can check the targets here for our Kubernetes cluster. Okay, now we need to add this Prometheus as the data source in the Grafana. So I will go to our Grafana server, and on the left side I will go to connections, data sources, and we have one data source which is our Prometheus server, which is installed in the EC2 instance. I will add one more Prometheus as the data source which has been installed on the Kubernetes cluster. So I will type here, I will click here, add new data source, Prometheus. Name I will give Prometheus EKS, and URL I will give http colon slash slash and this URL of the service. Colon 9090, and here I will click on save and test. So connection successful. Okay, so data source has been added. Now we need to import the dashboard for the Kubernetes cluster. So I will show you by adding the two dashboards. You can search for the dashboard ID and you can import the multiple dashboards for the Kubernetes. So here I will go to search and I will go to import dashboard, and here I will give the ID for one of the dashboard 15760, and I will click on load. So this is the name of the dashboard, Kubernetes pods, and the data source I will select Prometheus EKS and I will click on import. So this is the dashboard for our EKS. Data fetching may take some time. And here on the data source, in the drop down we need to select our data source, Prometheus EKS. So CPU usage by container, CPU usage by memory usage by container, all the graphs are available. Here if I select the namespace Prometheus, so we can monitor the pods created under the Prometheus namespace. I will go to home of the dashboard. So these are the dashboards which has been imported to our Grafana. I will show you by importing one more dashboard which is also for the Kubernetes. So in the search bar I will go to import dashboard, and here I will give the ID 17119 and I will click on load. So name of the dashboard is Kubernetes EKS Cluster. I will select the data source Prometheus EKS and import. So here we can monitor complete cluster. So we can monitor the namespace Prometheus here. You can search for the dashboard IDs and you can import the more dashboards regarding the Kubernetes cluster to the Grafana. So on our Grafana we have total 4 dashboards as of now. One is for Jenkins and one is for node exporter, which is the local host, and 2 are for the EKS. Okay, now finally we need to configure our Jenkins pipeline to deploy the resources on the Kubernetes. So for that we need to first deploy some plugins to the Jenkins. I will go to manage Jenkins, plugins, available plugins, and I will search here Kubernetes. I will select this plugin, this one also, this one also, this one also. Total 4 plugins I have selected. I will click on install. I will go to home. I will go to terminal of the server and I am inside the /home/ubuntu. Inside you can see one directory .cube. I will go to this directory and this is the config file for the Kubernetes. I will right click and download it. I will save it on my project folder. I will go to that folder and I will open the config file in the notepad, and I will do the save a copy as, and I will give the name secret.txt. Now we need to add these secrets to the Jenkins. So on the Jenkins, I will go to manage Jenkins, credentials, add credentials, kind. I will select secret file, ID I will give Kubernetes, and I will choose the file which we have just downloaded, and the ID is Kubernetes. This ID we will recall in the pipeline script create. I will now go to my pipeline, configure. I will go to script, and here we need to add one more stage to deploy the resources on the Kubernetes. So here I will add the one more stage, and the name is deploy to Kubernetes. Now it's okay. So I will delete this command. Actually we need to generate this command, and directory Kubernetes. This is the Kubernetes directory inside our GitHub GitHub repository. Kubernetes, because this directory is having the manifest files. So I will generate the command here. So to generate the command, I will go to pipeline syntax, which will open the new tab, and here in the drop down select the plugin which we had installed, kubectl. Credential, select the Kubernetes credential, and remaining things don't change anything. Generate pipeline script. Copy this command and paste it on the pipeline script. I will click on apply and save. Before we verify our CI/CD pipeline, I will make one change on my pipeline. On the pipeline script, I will make it trivy image scan. Apply, save. While pushing the changes to the remote repository from your git bash, you may be needed the GitHub personal access token to be provided. So on the GitHub, you can go to setting, developer setting, personal access token, token classic, and you can create your token here. I have already created the token for myself. I will clone the repository on my git bash. I will go to repository. Okay, so I'm inside my repository. Before we verify our DevSecOps pipeline, we need to enable the webhook for our pipeline. So I will go to configure, and here I will give GitHub project. I will paste the URL for my repository, and under the build trigger I will select this option, GitHub hook trigger, and I will go to my repository on the GitHub. I will go to setting, webhooks, add webhook. I will give the URL here, http:// and the public IP of the Jenkins instance :8080 / GitHub hyphen webhook / add webhook. I will refresh here. It is showing as green, means connection is successful. On my project, I will apply and save. Okay, so everything has been set up. Now it's time to verify our DevSecOps pipeline. If I go to DockerHub, you can see there is no image for YouTube clone app. I have removed the previous image. So on my git bash, if I do the ls, I will modify the readme file. I will make it test 50. Control O and enter to save. Control X to exit. Git add. Git commit -m.
git push origin main. So here I need to provide my token. So I have already created the GitHub token. I will go to token option and I will paste my token here. So changes has been pushed to remote repository. If I go to my Jenkins job, so it has triggered automatically upon the change on the GitHub repository. Job completed successfully. If I go to DockerHub and do the refresh here, so image has been pushed just now, and if I go to my email, I have received the email also with the log from the pipeline. If I go to my Grafana dashboard, and if I go to the pods, I will select my source and the namespace is default. So data is fetching for the newly created pod. If I go to server and give the command kube ctl get service, so this is the URL of my pod. I will browse it on the new tab. So this is my application running. This is the YouTube clone app. You can play the videos also on this app.
शतरंज का डॉन तो मैं ही हूं। फिर
सर पाव भाजी आई है अमित जी के घर से।
New legislation.
We will verify it once again. On the application, the color of these symbols is red. We will change it to some other color and we'll verify it changes or not. So on the git bash, I will go to src directory. I will go to components and I will open the file sidebar in the nano editor. And this red color we will make it some other. I will make it blue. Control O and enter to save, Control X to exit. Git add git commit, and I will send the changes to the remote repository. Git push origin main. If I go to my pipeline, so job has been triggered upon the change on the GitHub repository. Job completed successfully. If I go to terminal and give here the command kubectl get pods, so these are the newly created pods. We will check these pods on the Grafana. On the Grafana dashboard, uh, namespace is default. In the drop down, I will select the pod, this one, and if I do the refresh, so data is fetching for the newly created pod. And if I go to my application and do the refresh here, so you can see the color has been changed for these icons from red to blue. By this way, you can create the complete automated DevSecOps CI/CD pipeline, which will trigger automatically upon the change on the GitHub repository. And once job is completed, you will see the changes appearing on the application. Follow me on the LinkedIn. I post multiple useful things on the LinkedIn also. You can fork my repository and create your own branch and practice the complete video. During practice, if you face any kind of difficulty, you can ask me in the comment section. I will definitely reply to your query. Hope you find this video helpful. A lot of effort went behind this video. So do subscribe to my channel to encourage my work. Like the video, share this video with the friends and spread the knowledge. I look forward you to join me in the next video. Thank you.